This is lesson 7.5.1 for Algebra 2 on complex numbers. So the couple terms we have to define this time are I, imaginary number, and complex number. So I is the imaginary number. So I represents the imaginary, and the definition of I is really that I equals the square root of -1. And then if you were to square that, so if you were to get I squared, you square this and square this, these chunga, and you get I squared, I squared equals -1. And then if you raise that to another power, you end up with I cubed equals negative square root of -1. And then I to the fourth is kind of the ideal because I to the fourth equals 1. But this is the big piece that we're going to be focused on in this first section. The next term is imaginary number. So the imaginary number is the square root of a negative number. So for example, the imaginary number would be like the square root of 16 is 4 or -4. And the square root of -16, if you type it into a calculator, it'll tell you non-real answer. The reason it says non-real is it's an imaginary number. So there's an imaginary solution. And what we come up with is 4i and -4i. The I is because of the negative that's under the radical. The last term is complex number. So a complex number is a number that has two parts, both a real and an imaginary part. So this is a combination of a real and imaginary number. So what that looks like is you might have, the general form is a plus bi. I'll put some numbers in it too, but a plus bi is an example of a complex number. A is the real part, and then this bi is imaginary. They always put the real part first. It's just kind of mathematically agreed upon. So this is an example of a real number. Or sorry, a complex number. This is the real portion, and this is the imaginary portion. So to look at a couple examples, if we look at A and B, these are the most common and simplest examples of imaginary numbers. So the square root of 4, if this wasn't negative, the square root of 4 would be 2 and -2. But because of this negative right here, we need to put an I on both pieces. So those would be our two solutions. Then the square root of 100, if it wasn't negative, we would know that it was 10 and -10. But again, because there's a negative here, we need to include that I for the imaginary portion. Now, part C and D, this is a little bit tricky because we can't actually square root 11 or 10. So in this example, what we would do is simply pull out an I in front. We'd say it's I square root 11 or -I square root 11. There's always a positive and a negative option, positive, negative. And then this one, the reason the I came out is because, again, I is for this negative that's under the radical. For 10, we would get I square root 10 and -I square root 10. Now, parts E and F, these are the last two that we'll practice with actual numbers for right now. These ones can be simplified. So I know you guys have seen this in your other math classes before, but basically what we're looking for is a number that these are divisible by that are perfect squares. So for example, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. These are examples of some perfect squares because 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 7 times 7, 8 times 8, so on. So what we want is to be able to take the square root of one of these and break this into that. So what I mean is 4 times 2 times negative 1, this 4 is in the list. So we can break these each into their own radical. The square root of 4 is 2, but I'm going to do plus or minus 2. The square root of negative 1 is I, and then the square root of 2 is just stuck there. So just to make this a little more clear, if you want, I'll write them separately. It's 2I root 2 and negative 2I root 2. Those are our two solutions. We'll do a similar thing here. We want to find a number in this list that can divide 75, and that number is 25. So they each get their own radical. Square root of 25 is 5. Square root of negative 1 is I. And then the square root of 3 is just the square root of 3. But technically we had plus or minus. Sorry, I forgot about that. So our two options are 5I root 3 and negative 5I root 3. In these four examples, what we're going to do is use our normal PEMDAS SADMEP to solve for x. And then it says to plug it back into the equation, but I'm not going to have us do that. I'm just going to have us kind of solve for right now. So first thing we have to do here is subtract 3 on both sides, and we get x squared equals negative 3. Then we square root both, and we get x equals negative square root 3. Whoops. Negative square root of negative 3 and positive square root negative 3. But again, you can't have a negative square root, so we'll call this x equals negative I root 3 and x equals positive I root 3. I'll try to do one more. Hopefully we won't get cut short, but if I do get cut off, I'll start on the next video. So here we'll minus 36 on both sides. We get x squared equals negative 36. Square root both, and we get x equals the square root of negative 36 and the negative square root of negative 36. Well, this ends up being 6i, and this is negative 6i. Because this negative here, and then the square root of 36 is 6, but the negative gives us the I. Here the square root of 36 is 6, but the negative gets us the I. All right, I'll pause this. We'll do the next one on the next video.